Welcome, fans of flip clocks. We're looking at a very unique clock, a rare clock you're not going to see many of. It's a compact alarm clock from Copal, Japan. It's got a chain that you have to pull to get the motor started. Well, we've got it running, but it did take us quite a bit of trouble here. We're going to go through in detail what we did. This is a Copal Model QP-212, 12-hour, runs on a D-cell battery, made in Japan. I've completely disassembled the clock, and we've got the motor and the mechanism apart. First thing I wanted to do is to make sure the mechanism itself wasn't bound up or causing trouble. Now this is a little operation indicator, or like what we like to call a whirligig. It's completely independent of the clock mechanism, which is unique, but it's very critical in a clock like this. It's crucial. So this is the motor, and it is unlike any I've ever seen from Copal, and there's probably a reason for that. It's not very good. So there's a wheel on the bottom, and if you see, there's a blackish gray wheel on the top that sits around this coil, and both of them spin due to the magnetic field that's created by that coil. The bottom one impacts this gear right here, and it is spinning. You may not be able to tell that. I've had it spinning for a while to make sure that this wasn't the problem. It doesn't generate much torque, but that's what's going to run the whole clock. I thought for sure it was going to be some of those capacitors, but it turned out it wasn't. Now this wire here, you had to desolder that to get this clock apart. You can't get this plastic case off until you desolder that from that post. So, and then I had to do some screwing. I had to unscrew that circuit board to get the last screw off to get the mechanism off, the gearbox, I guess. It's fairly straightforward to get this clock apart, but you just have to hunt for the screws. Now if you look here, there's these two posts here that come out. That one of them is going to impact the whirligig, and the other here is going to run the clock. Now the gearing has to take that little bit of torque and ramp it up so that it can run this clock. You see the gear a plastic gear will fit in there to impact that gear there to turn the clock. It's pretty straightforward, but it's got to generate a significant amount of torque to do that, and it does that through the gears. Again, we're still running here, you can see. So it's not the problem with this at all, but it doesn't take much force to stop that motor, and that's probably why this is wasn't a very popular clock. It would easily get stopped. Now what is stopping our clock in this case is this mechanism, and it was gummed up. It was moving, but it wasn't moving well. So I took it apart, and I didn't really know how it was supposed to move anyway, but I found that once I oiled this up, and look here, this chain, it's not, you see here, it's not pulling the chain that starts the clock, it's actually releasing the chain that starts the clock. So some people, I think, are aggressively pulling the chain, but it's the releasing of the chain that causes the gears to spin in the correct direction. The spinning of those gears will cause the motor to get started, those wheels to turn it. Now you can see when I spin these manually, it's got some momentum. It keeps going. It wasn't doing that before. It would spin, but not like that. Now what I had to do is I had to take this all apart, because each one of these points here, it's like on a grandfather clock or a mantle clock. Those points are oil wells, and I had to oil each one of these spots here and then work it a little bit to get things going again. I'm guessing the oil just dried up over the years. They probably didn't intend for these clocks to be oiled. I don't expect they expected people to collect them like they've done. But once I got that oiled up, it started working a lot better. So again, that little doohickey there, any little resistance will stop that in its tracks. So it doesn't take much to just touch that and it'll stop. So even if you have the clock running and you accidentally pull the chain just a little bit over here, it'll stop that motor dead in its tracks. So this is how it fits in. You can see where that impacts that little plastic wheel there. And then pulling it and releasing it will get that to spinning. There, you might be able to see the little plastic wheel there spinning now. To make sure, you have to look at the top, and there's gears there that should be moving. And sometimes if they're not moving, that'll vibrate back and forth. You'll hear a sound, but it's those wheels vibrating back and forth instead of turning round and round. So it's a really quirky design and frustrating at times. Now, a side issue on this clock was the alarm, and it's got a very unique alarm. This is a buzzer here, a piezoelectric buzzer, probably. First I thought it was a typical old clock where it had the two metal pieces vibrating together, but that's not what it is at all. So if we set the clock to say 2, turn this around, and you see what happens. When these two are touching, and they really shouldn't be at this point, because when they touch, that's what sets the alarm off. So when you hit to 2, you see there was a movement there, but there's no change. They were already touching. So when I first got this clock, it was alarming all the time because of that. So you see that there should be a separation there. Now why it's ended up like this, I don't know. I have a feeling the clock may have been dropped at some point and it just jerked everything around a little bit, but I don't know that, or it just shifts over time. But what needs to happen is this arm here, I need to adjust it so that it's not touching at this point. So that would cause that not to complete the circuit. Again, it's not vibrating like a lot of our older clocks. This is just completing a circuit to set the alarm off. So I want to make sure they're not touching. Readjust here. Tighten it up. Get it pretty tight in here because I don't want it to happen again. So they're not touching there. Very little space. Now you see when I turn it around, you should see it jump there. Well, did it? It'll move together and touch. There it is. There, it's separated. That's it. So that's why the alarm, if you get an alarm like that, that's what's going on. So it's a pretty simple fix, but you do have to get the clock apart. You don't have to take the motor off to fix that. So we've got everything together, and we've got this wire soldered back where it goes. You can see you'd have to have that off to, there's our battery in place. You'd have to have that off to get that plastic cover off. The arm's working. I'm going to start this sucker up, and sometimes it takes more than one try here. Now if you see that whirligig is going the wrong way. I had suspected that these clocks could run backwards, and it in fact was, and I believe that's actually what caused some problems in the past. Those clocks can run, you can actually set them off wrong. Now we see it's working good, and I would imagine the instructions told you to make sure that wheel was running upwards. But we don't have instructions when we find these clocks off eBay. So there it is, the Copal Model QP-212, a very quirky little clock. It's been running for 24 hours now and doing okay. So we'll get another clock back out in the world. Hope this helps somebody. Thanks for taking the time.